Good morning, this is Dr. NSSR Murthy. We are talking in the next lecture of the GPS, that is the GPS navigation message. GPS satellites send messages to the GPS receiver, and that message is called the navigation message. This is the message is sent by C by A code. So the message contains information about the clock set of data. That means as we said earlier, that there is a difference between the error in the GPS clock time in the GPS receiver and the satellite atomic clocks. That difference is calculated through this clock offset data, and similarly orbital data of the satellite, and also it contains the neighboring satellites, constellation satellites neighboring data also will be there, and other the correction factors required at the GPS level are also sent. So it is sent through a 50 bits per second signal by means of a BPSK modulation using the C by A code, as we said earlier, and P code. That is actually a 50 Hz navigation message is superimposed on the both C by A code and P code. P code is the precise code, and C by A code is a normal code used by the public, and the message has information of the unique data of the transmitting satellite and also the neighboring satellites it will contain. So normally the navigation message has 25 data frames in it. Out of this 25 data frames, each data frame is subdivided into 5 subframes. So of each 300 bits, that means the total data rate of data frame will have 1500 bits length with 5 subframes, each was forming as 300 bits, and the transmission time it takes is 30 seconds for each subframe, each data frame. That means 6 seconds it takes for one subframe, and total 30 seconds for one frame. Like that, 25 frames of the data will be communicated. So at the 50 Hz transmission rate, it is received at 6 seconds each frame. So for 25 data frames, the total time of requirement is 750 seconds or 12.5 minutes it takes for the communication of a single navigation message. The important elements of the message can be repeated. In every frame, some frames will contain the standard of this particular information about the satellites, so that it will be repeated. So normally the 5 data frames, 6 data frames can be considered to be like this. First subframe contains a header frame. Header is nothing but it contains the information about what it contains, the message information, and followed by satellite health status, and also the handover word. That means a code for the transmission from C by A to P code also contains. And similarly, subframe 1 contains the satellite clock correction data and the time of word, at what time the transmitted the data is started at the satellite. And satellites 2 and 3 subframes will contain the ephemeris data of the signal transmitting satellite. Ephemeris is nothing but it is the orbitals elements of this data, azimuth angle, elevation angle, all the information about the transmitting satellite will be called the ephemeris data. Similarly, the subframes 4 and 5 contains the varying data for which represents for all the satellites, like orbit and clock data of the different satellites. Normally, the satellite information, the subframes of 1, 2, 3 will be same, and 4 and 5 changes for each satellite. Now let us consider, as I said, the handover word is nothing but it is a GPS variable which enables the GPS receiver so that it switches from the C by A code to the P code. Switching is done using the handover word. That details are given in this particular thing. The subframe structure, if you see the subframe structure, if the first subframe is like this, it contains from the bit numbers 0 to 300, and it contains the telemetry word, that means the header information, the handover word, the conversion data, followed by the clock correction data of the satellite. It will be transmitted at the first 6 seconds, 0 to 6 seconds. then followed by the subframe 2. It also contains header information is same. Then it contains the ephemeris data of the transmitting satellite. Similarly, the subframe 3 also contains the ephemeris data of the transmitting satellite, and subframe 2 ranges from 300 to 600 bits, and subframe 3 from 600 to 900 bits, each separated by a 30 bits frame, different individual frames. Then followed by subframe 4 and 5. If you see this, it also contains the telemetry word and the handover words, followed by multiplex almanac data, which is different for different satellites. That is, it indicates all the changes for the 25 frames, and this data is important for the calculation of the neighboring satellites information, and the 2 and 3 gives the ephemeris of the transmitting satellite. This is sent within 30 seconds. This information will be sent, and this particular information that is received at the receiver is demodulated. It is a BPSK modulated signal. It is demodulated, and the information is extracted at the receiver end. Because the bandwidth of the message signal is very small, the signal to noise ratio is maintained very high, which is a requirement for this. This increases the accuracy of the position measurement by GPS. As long as there is a more accuracy in this subframe structures or for all the 25 frames, the position measurement will be more accurate. Thank you.